All right, let's jump right in. My name is Joe Brenner, and I am the BIM for Bridges Regional Technical Manager for Michael Baker. Today, I'm going to be talking to you about Dynamo specifically, and my presentation title is Dynamo Enabled Modeling, and we're going to be looking through specifically a bridge project example using that tool. So I'm excited to talk to you about this topic here today. I know this is a Civil 3D workshop, and I'm definitely not a Civil 3D expert, but I think it's still very important. I'm excited to talk to you about it today because I think this is a tool that maybe not many people have used before, maybe not even know about really. So I think it's important to kind of look at that, look at some applications there. And my goal for this overall presentation is to show you some examples from my experience, one in particular that's from recent experience, and hopefully have you take a look at that and think about how you can apply it to specifically your job, what you go back and do, because this is really more of a tool. It's not a bridge specific tool. It's not a roadway specific tool, or really any specific tool. It's a way and a method that we can use to automate some of these things and tie things together in a different way. So again, I'm excited to talk to you specifically about that. We'll see how much time we have. We want to make sure I give background on this, on the tool and the example here, but we'll see how if we can get into some of the outputs and look at how we can bring this into potentially some other software programs as well. So first, a little background on myself. I am a bridge engineer. That's been my background here since I got out of school. But really more for about the last 7 or 8 years, I've really been focusing on how I can use models, 3D models essentially, to generate our bridge deliverables, so deliver bridge projects. So I've been working on that. Got my start really with Autodesk products, actually, with some Inventor and Revit models that we created, and then created a viable workflow in order to generate our 2D drawings, quantities, and other deliverables directly from a 3D model. So since then, been working, continued kind of working and developing more in the digital delivery aspects of this, and have been working kind of on the national level on some of the efforts to bring and implement digital delivery. Worked with FHWA and led some of the FHWA BIM for Bridges and Roadways efforts as well. So again, just a little bit of background of where I came from and where we're going to be headed here specifically, how I've used these tools in the past, and again, how maybe you can take it and use this and apply it to your specific workflows. So before we get into the actual tool, I do want to kind of take a step back and look specifically at model-centric bridge design, and really just model-centric design in general, and give some background there so we can kind of set the stage for where these tools can be applicable and add value. So here, this is a diagram, very simplistic diagram, but I really like it. I've used it on many presentations before. And really what we're trying to get out of this is that the 3D model is essentially just a central repository of data, okay? So we enter that information in one time and use it for multiple applications. So you can see some of them up there on the top of the screen on the bottom, some post-design applications down at the bottom. We won't get into too many of those applications here specifically in this presentation, but that's really where a lot of the industry is moving to. So we can use these models beyond design and really look at it full life cycle costs. I know there's presentation next on digital twins, so really looking at that. Again, we're going to be focusing on kind of the design side for this presentation. And specifically here, I have a few of the applications or different tasks from design boxed. So we'll show how we can use these model generation, these 3D models, for the basis for our visualization tools. Show some examples of that. Preliminary engineering, look through different applications, different scenarios, alternates early on. We'll show how we use the tools to do that. Design and analysis. So this is one that's particularly in the example we're going to show is one that's really really key. And actually, we've used a lot of that data to generate our 3D model. So instead of starting with more of a physical model and going to an analytical model, we actually used a lot of that data before because we had it available to us. Okay. Also, we'll look a little bit and show how we can generate 2D drawings from that data. Essentially, as we have that model now, we have the ability to create drawings and views from that, as well as quantities as kind of a byproduct. So what does that all mean? What is model-centric design? What can we do with it? So it's really important to understand that this is not necessarily just an easy button here. All right, we have the ability and we can add value to our projects through this. And some of the ways we do that are through view and interacting with design. Okay. We're able to integrate content from multiple disciplines. We'll show a little bit of how we can do that. Also, look at situations like constructability or construction analysis, simulation. Again, we're talking about specifically in design in this. Drawing generation, we'll talk a lot about parametric functions. We'll go and get in the next slide and give you an example of what that really means in terms of parametric modeling. Reinforcement schedule is another really good one. We won't get into specifically in this presentation. That's another great application used for these 3D model-centric design, and really look at structural analysis applications. So we'll show how we're using some of those tools that can interact directly with that structural analysis, specifically with geometry and some of the structural attributes, to be able to use that as well. And I mentioned some of the post-design applications. We won't specifically talk about this in that presentation, but wanted to give you an overall, why are we even talking about model-centric design? Where that value added overall in the process? Okay. So specifically for parametric design, here is an example here. And really what we're talking about is we're building in logic, and we're able to control not only geometry, but smartness, if you will, for our models by using parameters and building in this logic. Okay. So this is an example. It's not even really a bridge. It's a culvert structure, a three-sided culvert structure. But I think it does a really good job of giving an overview of exactly what we mean and what it means to have parametric design and how some of these things can be tied together. And this is developed in the Inventor, Autodesk Inventor software. Again, I got a lot of my start in really good generic Autodesk software here that's used for the basis for InfraWorks as well. So here again is our three-sided culvert. You can see some of the roadway shown in kind of a transparent material there, culvert in green, wing walls in blue, and some curbed in yellow. So as we get down here and show you some more of an elevation view, you can see some of the accuracy in the model there with the vertical curve of the roadway structure and the curve following that. So we're talking about accurate models here. So now what we're going to do is go through some of these parameters. We have some of these specific, what we call forms here, where we're entering in inputs. These are what you're seeing as kind of the user interface, if you will, of those inputs. So we're actually just providing the parameters, but behind the scenes there's equations and logic built into these models. Okay. So now as we go through and change some of these different parameters here for lane width, shoulder widths, we can change the skew angle of the structure, if you will. We can change the span length, okay, wing length. All right. And as we do that and we hit update, we see that not only the specific parameters that we specifically changed with our parameters, but also other parameters such as the footing now that's tied to the span length. So it knows it has to expand and integrate with these new parameters. Okay. Skew as well. Okay. It knows that skew. It's smart enough to understand that it has to shift and adapt to these new parameters based on the logic. So we can change the skew to the other direction, again, change the span length again. Okay. So now, again, we've essentially looked at three different versions of that model, right, based on the different parameter applications. Okay. So this is especially good for things that looking at alternates, obviously. Another application we've used this a lot for is looking at specifically where we're looking at bridge bundling or structure bundling, where we have multiple applications, multiple structures that are very similar in terms of detail, structural detail, but just have different site constraints, skew angle, span length specific that what a need for those specific sites. But we can build in that logic in these models so that we can quickly generate multiples. We can look at different alternates, what it would be like that, and tie all our deliverables to that as well. So just wanted to give you a little bit of background specifically on parametric design, what that means, what that looks like as we set up into looking at Dynamo and some of the tools there as kind of the next step of that and how we can use those parameters with those tools. So just wrap up with model-centric design. Again, really what we're trying to do overall in this process, look at, we want to make sure we have a single source of truth. So again, that information is entered in one time into the model, and we're using that for other applications. We're not keeping, tying that information to multiple locations that could be disjointed and not used, even specifically with the analysis, structural analysis, and our physical model here. The ability to respond to changes, you saw that in the example here before, the ability to, make an update, and not only that, component updates, but because of the logic we have built into this, other changes happen as well. Okay. We're able to automate quantities, right? It's kind of a byproduct of doing things in 3D, but now we have that ability to spit that out. We can generate plans, rebar schedules you mentioned, and visualizations is another one. I don't want to breeze over that. I think a lot of times we say, yeah, it's pretty pictures, but really we're talking about engineering grade visualizations in many cases here. So we're talking about the ability to kind of build our structure in design, early on in design, from the ground up. So I think it's very important to make sure we don't just breeze past that. Okay. So now that we've kind of got a background, make sure we're all on the same page in terms of model-centric design and specifically what that means for bridge design and what we're going to go through this example, although it has applications to other disciplines here. What I want to get into now is specifically looking at what is Dynamo and what does now this next step of computational design. Okay. So first, what is Dynamo? All right. So first, I guess we should make sure that everybody's aware that Dynamo is a specific software package. It kind of works as an add-in within Revit. Okay, so it's automatically downloaded with the Revit program. It also does work with other Autodesk software, including Civil 3D. So what we're talking about here can be applied and used within Civil 3D to automate some applications here. So keep that in mind as we go through that and we go through this example. Okay. But really what we're talking about and what this is a visual programming tool specifically for designers. Okay. So every time we get in and we talk with engineers, at least civil engineers, structural engineers in particular, from my background, anytime we talk about programming, I think we get some people that will take a step back and say, hey, I'm not a programmer, right? I don't do code. Okay. And I get that, because that really was where I started, and a lot of the people that I work with have no interest in programming. I think it's important to understand that there's some really let's call it specific and flexible things that you can do if you have that ability to program. But what we're going to show, the example we're going to show here today of this truss structure, this truss bridge, was done all without any programming. I did no coding specifically here. Okay, but with this visual programming interface, if you will, with Dynamo, we're able to use custom algorithms to automate some of our process, okay, to repeat repetitive tasks, okay, certain applications, especially when we have information already available to us, like in a spreadsheet that we had in this particular case. So we're going to show you how we were able to import all the geometry that was already included in a spreadsheet for us here, okay? And really, we'll look at how we can generate complex geometry from this visual programming tools and script, okay? And what I definitely want to get across this is this presentation, this example is really only scratching the surface of what you can do with some of these tools. They are incredibly flexible. You know, a lot of times we run into issues specifically with limitations with software. You know, a lot on the bridge side just because it's a little less mature. Most of these are geared towards vertical structures, right? And like Revit got its start with vertical structures, right? But because of the flexibility of this tool, we're able to do some things that we couldn't with the bridge specific tools, for example. Okay. And you know, there's a library of nodes that are what they call nodes that are available to us that we can pick from and essentially just pull from our library or buffet to put into our script and to be able to use for our algorithms. Okay, and I'll show this example of this as we go through and get into the actual content here. But as I mentioned, it really allows for a lot of flexible solutions. You know, it's not it's more of a free form solution rather than a bridge specific or having to use specific tools here. Okay. And really where I see this and coming forward is where we see this going is enabling fully computational design with these tools. Okay. And we'll get into more about what that means and what that looks like. So first, just kind of a background on computational design. You know, really we're going to start, we're looking at, think about a spreadsheet, right? We have inputs, we have those inputs go into a function, right? So it could be mathematical, you know, could be graphical, could be a conditional statement, specifically looking at Excel, okay? And then we have some sort of output that comes out of that function, okay? Could provide one specific output, could be multiple outputs, okay? And what we're going to and what we're really looking at when we start getting into these visual programming tools like Dynamo is we have the ability now to have a script, okay? And it's essentially that. Now we're actually running inputs, but instead of one function that's kind of linear, we're able to tie together multiple functions. We're able to look at that in functions in parallel and kind of a network of those functions that are able to propagate downstream outputs. Okay, so really that's what we're doing. We're tying those functions together in a logical way that we can use and look at multiple things at one time instead of just straight input, function, output. Okay. So specifically, when we get into computational design, I really like this quote. You know, I like this quote because I'm using it. It's from one of our competitors here. But I think this is the best, most concise definition of computational design that I've come across anyway. And he states that computational design is the change in medium from design expression from geometry to logic. Okay. So it's essentially moving from, you know, geometry, our CAD, even some of our 3D models that we have there, to now we're actually making that, we're generating that from logic. That's our design. Our design intent is being expressed through logic. Okay. So having that in kind of a separate, how we've done it traditionally, having a separate logic and then conveying that in design, or excuse me, in geometry. Now we're really kind of combining that now, where we have our logic, our design intent conveyed as logic that comes out through, and we're able to use that, and it's enabled through some of these tools. So I hope that's at least starting to become clear. We can discuss this further in any of the chats. I'll try to keep it as interactive as possible as we can with a recording here. But if you have any questions about that, or you want to discuss that more, put that in the chat, and that's something we can certainly tie into here at the end of the presentation. So here's an example of this. This is actually with using a different visual programming tools. This is a program called Grasshopper that works with Rhino 3D. But again, I think it's a really good application, a really good example of how we can tie and create our logic now instead of just working with specific geometry. Okay. So here we have a curved steel girder bridge structure. You see that at the top. And then at the bottom, essentially what we have there is a flattened, simplified geometry version that we're using. That is actually our analysis or analytical model. Okay. So we have, we're not creating two separate models. We're using the same geometry for two different applications there. Okay. So what I'm going to do through this example here is we're going to actually change the web depth on our particular girders. Okay. And as we go in here, and you can see kind of the script there, I'll go through all of the, what those nodes mean and the application behind there. We'll, specifically for this example, we're going to show you how we can change the web depth here. And this is in real time as it kind of updates here. So not only the girders, the physical girders update, our cross frames that are all applied and applicable to that update as well. So they know they need to stretch and get larger. That geometry needs to change. That logic needs to change behind that. But not only that, now our analytical model that's tied to that below also updates as well. Okay. So again, we're tying that in. So we're not specifically just looking at geometry now. We're tying that logic into how we build, and you can tell by some of the analytical models here that we're going to using things like shell elements for web, going to the center of the girder here. You can kind of see, if you look really closely, some of the rigid links we have between to set that up between the deck and the girders. So we're starting to tie together much more of our logic instead of just working essentially from our logic to and then putting geometry into our model or into a 2D CAD drawing. So specifically looking at the different software involved here, we specifically for Dynamo, looking at this, and what our example is going to show, you can see in the top left corner we have Revit shown. This is really looking at specifically Revit as a visual interface. Any geometry we need to use, we can show you how we've used that. You can always use, obviously, the Revit tools for that. Another thing that we've used is we've be able to use the Revit libraries. We'll show you how we can do that through Dynamo. Through there, again, looking at the middle here, we're specifically talking about Dynamo as our major visual programming. This is where we're developing and pulling in our parametric geometry. We are linking to our input, specifically coming from down here from our Excel sheet, our spreadsheet, as well as Dynamo, and our inputs just directly from Dynamo. And as I mentioned, really we're able to, one of the big things we're able to do, and one of the powers of this is we're able to link to our Revit libraries. So we'll show you how we can create families or use the preset libraries, family libraries from Revit, in order to generate some of our structural members, which really saves a lot of time and makes this much more efficient and effective. Okay. And we can even define outputs if we want to. And really what we're using is using it as an automation engine. Okay. Specifically for our example here, we are literally linking to a structural analysis program, which is Midas Civil. In our case, we're actually generating, it's kind of going back, starting at Midas Civil with some of the geometry that we use there, and using that and pulling that into Dynamo, modifying it as we need it, but actually using that, and that's definitely a two-way arrow there between those two applications. And then finally, look in the right-hand side of the screen, looking at some of the results, quantities, things like that. The visualization results is extremely important. It's very kind of a byproduct of what we do here as well. And then specifically on the analysis side, obviously we have our design stresses and codes. All right. So we're trying to link this data as much as possible, and just wanted to give you kind of a map. There's a lot of software going on here, and even more so here, trying to limit that, but show some outputs of where we can go to InfraWorks or Civil 3D as a generation of some of this geometry that can be generated and brought in and linked to these other applications. So I hope that gave you a little bit of background of where we're headed, and kind of background of Dynamo, parametric design, and computational design, and kind of how they fit. So what I want to do now is really dig in and do a demonstration of an example project here for a truss structure that we developed using Dynamo tool here. Again, to not necessarily, this will be a little bit different. It'll be a tool that's not, or a situation that maybe many of you do not see in your particular workflows, but I want you to take a look and kind of look at how some of these nodes and how some of this parametric and computational design applications are applied, and see where you maybe can apply that to your specific workflows. Okay, I'm going to turn my camera off here and going to get into really the bulk of what I want to talk to you about today, which is the demo of this tool and looking at some of what it can do, the applicable nature of what it can do with this example. So here is our example. This is a 3-span truss structure here. I'm not showing, I've kind of isolated just the truss members here that we developed with the Dynamo tool. But if I go to more of an elevation view, you can kind of see the accuracy here following a vertical curve of the structure here. And as I dig in here and get a little bit closer to some of the elements, we can dig in here a little bit and look at some of the truss members here. So real easy, try to dig around and make it as easy as you can, as easy as I can to pick things out. But here, we have some floor beams here that we used, and these are all created through Revit families. All right, so one of the advantages of using this is to be able to use the Revit families and some of the Revit tools to be able to develop that. But we have floor beams here, custom floor beams. We have W sections here, regular W sections for some of the bracing, top and bottom. You can see here. And what made this truss interesting here is some of the we call double sections. You can kind of see that here with these sections, where we're actually welding two W sections together for strength here instead of making custom sections. So we're welding two W sections together there, and you can see some of the struts coming up through there as well. So a very interesting structure. I think part of the toughest part was getting the Revit families correct. And if you've ever used and worked with Revit families, you know that can sometimes be more of an art than a science here. But I did want to give you an overview of this is kind of where we're at. This is we're still in preliminary engineering, preliminary design for this. I wish we were a little bit further along in the process here, but you can still see how we're going to use these tools here, these Dynamo tools, in order to populate and produce this massive truss structure here with many different members. Many different points, obviously, and different aspects there. So we're going to go through and show you how, again, we can use that tool here to create something like this in a very efficient and very effective way, in a very flexible way as well. Right. So now what I'm going to do is open up just an empty file here. All we have is an empty Revit file with some libraries preloaded. That's all that's included in this file. And what I'm going to do is open up and launch Dynamo here and show you some of the different aspects of that before we run this script and produce our truss model. So under the Manage tab, we find Visual Programming group over here, and we can launch Dynamo directly from that. We're not going to get into Dynamo Player here today, but that's another interesting kind of spin-off of what we can do with Dynamo, kind of limping together multiple scripts. Is another interesting aspect of what we can do with this program. So Dynamo opened up in another window here, but I'm just going to go ahead and open up my specific script here. So now my script is launched in Dynamo. You can see that here. If I zoom out, you can see the extent of this, and we don't want to overwhelm you here on the first the first time looking at the script. We'll walk through exactly what these pieces mean, and I'll show you that really most of these other lines here, kind of coming down from that, are essentially copies of my original script that we've used here, that I have up in here in color. Okay. So before we do that, just a little bit of an overview of the user interface. Okay. So I'm not going to go through all this again. This is not really meant to teach you how to use Dynamo in an hour. Okay. This is much more of an introduction course here, or an introduction presentation even. But I did want to show you a few things that as you get started in this, you can use and play around with. Okay. So here we have library. Okay. So this is our library where we have many different nodes. Okay. And what nodes are any of these kind of boxy looking information here. Okay. So we have these nodes are what the functions are. So we can see some of the inputs here for this. This is a translate geometry. And if you hover over it and give you some description of what it does, okay. And we have these strings coming in here, which are actually leading the inputs. So in this case, we have a line coming in here for an input for geometry. And then we are translating that line by a certain number, in this case, for another input, okay. And then we have our output on the other side, which is actually in this particular case, the transform geometry. So just like we talked about in our PowerPoint, we have inputs coming in, we have functions happening within these nodes, and then we have output coming out. And what's unique about this is now we have many different functions coming in as output of one and input into another. You can see here for some of those different geometry here is in this case for our framing elements, now creating that and using that output from that specific node for the input into this. Okay. And we'll go through the specific script here and show you what we're doing with these particular nodes in a second. And the library again has many different nodes that you can use. There's many different applications here. There's a search ribbon here that we can look and start to type in what we want to do, and more of these different nodes will come out that we can use as in our script here. Okay. So this is, I mean, a lot of getting familiar with this is just understanding what nodes are there. Again, the search tool is extremely helpful. Honestly, I learned a lot through this. I don't think I ever took a formal Dynamo course. I learned through YouTube, searching different forums to look at, hey, I want to do this. You know, are there any nodes that are out there that do this now? Or, you know, how can we string some nodes together in order to do this? So there's a lot of different forums out there, really great forums that you can find a lot of good information on and be able to solve your issues and what you're trying to do. Okay. There's also specific what they call add-on, and these are packages that have been developed by kind of third-party developers that you can go and download and have available for your use, and they just kind of, again, just like they say, add on to what's available in Dynamo, create some other nodes, some specific things that they can do. So there's many different packages out there for provided by third parties. So you can search through that and through the Dynamo libraries in order to find those libraries and download them as well. Okay. So now back to the script. Here again, we have my script that actually is going to create our truss model. Okay, so I'll zoom out again. You can see all the different lines here. And this has not been cleaned up at all for the presentation. Okay, really just wanted to give you an idea of what we develop here, what I developed specifically for this, and we'll go through what each of these functions do, at least an example, and then we'll actually generate our truss model here in front of you. Okay. So we have our nodes here. There's also, you can kind of see this in the background. So we have a 3D kind of navigation tool in the background that we'll be able to see, get a specific idea of what's going on in a preview. Okay. Right now we have that turned off. Okay, so we're on the manual run so that it doesn't regenerate every time that we change an input. So again, I can run this, and when I do that, you'll start to see that preview of what's being developed here. But an extremely helpful thing as you're going through your script and developing to make sure that it's doing what you actually are expecting it to do. Okay. So let's dig in. I have, you can see, colored groupings together, and what we're going to do is run through this and show you what we do. We're going to use the lower chord of our truss as an example of how we're creating this geometry and these sections through Dynamo. Okay, so the first thing we're going to do is to look at importing our geometry. So in this particular case, we actually we started with an analytical structural model of this truss, okay, from Midas Civil. And what we did is we were able to use that through some of the outputs there, and you know how engineers love their spreadsheets, but we're able to pull in the output directly from the analytical program, only entering it one time, okay, into that program. We're able to reuse that as the basis for our geometry. Okay, so through this first script here in green, or first grouping script in green, we're pulling in specific tab of a spreadsheet that has a geometry here. So here I'm just this is the actual spreadsheet. Okay, so again, not cleaned up for presentation here. This is the true, engineer spreadsheet. This is what we're using to develop, get our analytical design. Again, this is taking with the output directly from Midas in this particular case. So we're taking that information, and what we're doing is we're pulling that out into our specific needs for geometry for our members. Okay, again, all already produced, all the points are there. We just need to update it. And the other thing we're doing is now we're bringing in our civil 3D or our roadway information, and we're able to, through our targets, find specific elevations that we need to hit for vertical curve. Because in structures, if you're not a structural engineer, a lot of times in our analytical models, we'll simplify that. We won't show vertical curve, cross slope, those types of things. But in our physical model, what we need to develop our plans and, eventually, generate quantities, that kind of stuff, it needs to have our true geometry, if you are true or accurate vertical curvature and geometry. So we've also incorporated that here, again, just using spreadsheets, something that we use every day here, right? So with that, we're able to pull that information in. So that's what's coming here. I'm not going to go through each one of these here, but talk more to the groups. We're able to say, okay, this is the specific tab we want into our sheet name, and it will provide our overall data from our spreadsheet and import it into Dynamo for use. Okay. Now we're going to take each one of these points here, our geometry, and we're getting them all at our node points, right? That's our important part for our truss geometry, we are pulling that in and creating each one of those rows, or each one of those columns, I should say, parsing that out and creating our points. Okay, so now we're creating coordinates XYZ coordinate points that we're using as a starting point here for our script. And from there, we're creating the actual member center lines. Okay, and in our case, we're getting those lower points at the center, and we have these double section members that I showed before. A little bit interesting here. So we're actually creating our member center lines and offsetting them, in this case in the Z direction, for our lower chord members. But we can do that in any way. We can, here we're just essentially having number inputs from Dynamo, but these can be tied to spreadsheets. Probably what we'll do as we go further along in design is pull that out and have those as offsets in a particular input area. So it's more of an input for the user, so that they're called out, so we can make those changes quickly if needed. Okay, based on changing members, those kind of things. It could also be an equation based on CGs of members. As that change, we can automate that so that it automatically puts that center line in the right location. Okay. So from here, we're actually creating our structural framing. Okay, so this is where it's going into Revit. Okay, so now we're looking at, okay, we need to put it on a specific level just as part of those nodes. We're creating those specific framing types here. In this case, we're double sections. We're in some pretty beefy W sections there. Okay, but we're creating those lines that we just created with those offsets are now coming in as inputs, as well as these structural framing members. So we're able to, part of the power of this is being able to take those Revit families that we can use and modify and create what we need, and then be able to pull that in to this Dynamo script to use to automate some of these applications. Okay. From there, I'm going to pull up here. From here is where we actually create our floor beams from our members. So we're using that. Obviously, we can take those points that we got, and we're using those same points for the lower chord members. Right, they're all the same. We just have to make sure we're translating that and we're getting it to the right place as a start and end point for our new lines for our floor beam. So again, a lot of this is just figuring out how we can reuse that geometry, right? We can offset it, manipulate it the way we need. And again, here is our family type where we've created that custom floor beam member through Revit families that we can use here. Okay. And then finally, just to kind of close out that bottom chord member, we have our double section bracing. So those short kind of bracing members between our overall chords and overall lower bracing members. In this case, at quarter points along there, just for additional structure. But we want to make sure we have that in here for quantities, as well as weight and everything here for analytical purposes. So that's essentially our script. This is our script to create. In this case, again, we went through the lower chord. But now here, if I go down here, you can see that this is, as I zoom in, is the downstream lower chord. So we looked at the upstream lower chord, the downstream lower chord, and as we go through these different processes here, this is our upper chord, okay? And we have the same for diagonals, a little bit different. So you can see just some basic housekeeping procedures here. It can get a little bit crazy with your scripts. So I recommend using these groupings. I chose to use a grouping here for the first one, so I understood where those points are, and then essentially everything underneath it follows that same process. But you can, again, I would suggest using more rather than less of the groupings to kind of keep your nodes together into groups so that you can quickly find things and modify them. Okay. So now what I'm going to do is we're actually going to run the script. Okay. This is real time here, so I'm going to try to share screens here. It's a little tough with two screens, but I wanted you to see what it looked like here on the Revit side, as well as what it looks like here on the Dynamo side here. Okay, so I'm going to pull this down here just so you get at least a preview of what that looks like when it comes in as well here. Okay, so I'm going to go ahead and click run on my script, and after, as it goes through its iterations, you'll start to see the preview here on the Dynamo side, but also the actual structure members being populated here on the Revit side. So let's run it. So as you can see on my right-hand side, on our Dynamo side, you can see some of that preview geometry coming through here. And let me go to a little bit more of that and spin it around so you can see it a little bit better. Try not to make you seasick here. You can see that all that geometry has been previewed, okay? All right. So, and that was in real time here. So a couple minutes, that was able to generate that. And you can see on the Revit side here, I was just in a plan view, but you can start to see that line work here on this particular area is generated as well, okay? So here I've just removed the Dynamo window here so you can see it more in Revit. And now as I zoom in here, you can see some of the line work that's showing up here for the different elements. And here, as I go to a more of a 3D view, here you can really see the elements as well. Okay, so now let's see, you still have the blue lines there and the blue dots as it's still connected to that Dynamo platform here. You can see that we have those elements together. We're following geometry here. As I zoom in here, you will see a couple things that are a little bit different, right? So we're seeing, let me get a little bit better view so here you can see a little bit better here. There are a few things that are off, that are a little bit different than what the final version I showed you. One of them is the cutback distance. I think it has to do with the double sections and not being able to kind of really see the true center of those sections. But it gives additional cutback distance that we don't need. You can see how some of these members, and as they're coming into the truss members, are back. Some are actually extended further here. So this is something that we can modify manually here. We can add, and another thing, I actually ran ended up using the plates, the top and bottom chord plates, as well as some of the upper gusset plates. I ended up running that in a separate script. Okay, so again, this is preliminary in terms of what we're developing here, and it can continue to be defined. One of the really nice things about this is now we can use all of our Revit tools to modify this. We can isolate certain members based on labels. We can modify that cutback distance for all the members in a certain group. So this is definitely a something that you look and will need to be refined as you get into it, and as you even make iterations on your own designs. Okay, but again, as you can see, we were able to generate all that geometry here very, very quickly on something that I know I wouldn't want to do just with Revit or really any other tools with it customized like this for the specific situation. So what I want to do with the last few minutes is look at specifically, now that we have this model, what can we do with it? All right. So the first thing I want to do is right here in Revit, take a look at what we can do specifically with quantities, okay, and volumes here. So if I select any one of these members here, I can select multiple at a time here, but in this case, I'm just looking at a lower chord. All right. And what I can do is I can get different information from this just because we're in Revit and we have a Revit object now. Okay. So just going to roll down here again. There's many different options here that we can talk from here, but we have the length of every single member as well as the volume of every single member, and that can be turned into a weight. It can be scheduled for every single bar here. These are all, again, Revit elements that can be scheduled now. for quantities and individual and export it to Excel sheets and what have you. Okay, so that's the first, may seem obvious, but extremely helpful when we're talking about this, especially when we're able to update, maybe we want a different truss configuration, we change our script, we update that, our schedules are automatically updated as well. Another way we can use this model, or another output here, is by exporting to DWG and bringing that into AutoCAD in this case, or Civil 3D, the same process here. So we're able to pull that information in. We have our full truss model here that's now solid. You see I've isolated even more information here. You can see the deck as I move in, as well as substructure units, barriers, those types of things now have been added as well, bearings. So we have more detail here. We can build upon that and bring that in, bring in our roadway corridors, any information we have to that. One thing I will say that this is still an export at this process now. I know there's some additional ways we can go through InfraWorks and then back out to Civil 3D, but in terms of direct from Revit to Civil 3D, the best process I found is a direct export with DWG. We can use shared coordinate systems so that we can pull that back and get the information in the correct location, if you will, in the coordinately correct file here within Civil 3D. But that is one thing that I would like to see as far as a direct way that we can keep these models a little more live between Revit and Civil 3D. Next is drawing generation. So here you can see we have several different drawings that we've developed using the model here. So these are all generated directly from our model for our truss bridge here, or substructure. So again, we have that model now as output. We pull it into AutoCAD or Civil 3D, and we're able to make these drawing updates generation through that same process. No additional line work needed. So I'll run through a couple more. Here's more, again, the preliminary drawings that we've developed. You can see the truss gets a little bit difficult to understand, but we can hide different members, sections there as needed. But again, the important thing to note here is that we're generating that directly from our model line work, and then just annotating right on top of it. No additional line work here. And same thing for substructure units as well. Another really applicable and helpful use of these models, especially in preliminary design where we are, particularly in this project, is the ability to use them as the basis for visualizations, right? So we're using the true engineering grade models. We're able to tie in coordinate system here. We're using programs like InfraWorks, those types of things, so that we can have a starting point and then clean them up there in terms of making them look a lot better for, so we'll call it the pretty picture type visualizations, right? So here's a few examples that we've had specifically for this truss bridge. You can see some of the detail that we're able to get. Obviously, these programs are able to do things like mirror the image of the water of the piers. Keep moving through those. Here's an actual photo here that we can tie in those as well. Another way of using these 3D models for visualization, and then even into things like drive-through here is an example of that. Looking at the truss, kind of get a really good idea before we're there, where we're actually driving through and looking at what that portal looks like through the tunnel. So really good aspects. And again, these are completely to scale. These are the true preliminary engineering grade models that have been developed as part of this process. Here's another image as well. One more way in which we've used these models as a basis for kind of these spherical images. So here we have specifically a spherical image that was developed from drone photos here for a structure. You can see we have different what we call hotspots here, where we can tie in here. Is looking at some of the different applications here, or the different alternates, I should say. So if I click on one of these alternates, I can go into that same view of our truss bridge. So we can go to different views, use that as that type of a vehicle here to move through that. We also now have the ability to generate spherical images of our actual model files here. Okay, So this is something we're actually currently working on. Wanted to get something in here for you quick. This obviously we got our piers sitting on top of the trees, so we're still working on bringing that in for this particular application. But you can see that we're able to kind of tie that in and have that immersive experience within that using our true models as the representation there. And we can even move to other views here. Where we're able to kind of pull that together as well from another side of the view, be able to see that through this image here and through our structure as well. So I hope that gives you an idea of what we can do with these models for outputs, looking at specifically drawing generation, the ability to generate quantities and schedules, as well as some pretty high level visualizations from these models and from these engineered grade models using these tools. So I want to thank you in closing for your interest in my presentation, and I hope it gave you some ideas of how you can take this back to your desk, use some of these tools such as Dynamo to, again, go through your workflows, how you can automate some of these repetitive tasks, for example. So I believe there should be a few minutes left to take any questions. I've been trying to answer them as well in the chat as they've come in. But again, just wanted to thank everyone for your attention and your interest. And I look forward to having a good discussion afterwards. Thank you.